grade 11s, we're on to this third level of trig equations, and fortunately it's not too different to level 2. So the thing that's going to pop up in level 3 is the fact that we're messing with the angle, but instead of having a 2 theta or a 3 theta, there's like a theta plus 10 or a theta minus 50. So that's what we're dealing with in this video. So let's start with our first example. Solve for theta. Now I'm going to write down our steps as we go, but so far hopefully we've learned that our first step is we need to isolate the trig ratio. So whatever, if it's sine, cos or tan, my first thing is I need to isolate it. So in this example, that 2, I don't want that to be there. So I'm going to divide by 2 on both sides, and I get negative 0,6. Now just to reiterate, I know for cos, my ratio has to be between negative 1 and 1. So that's called interval notation. Now that's true for cos and sine. It's not true for tan, but for cos and sine it has to be between negative 1 and 1. And so negative 0,6 is perfect. Now a lot of people will be tempted to minus the 10 now because they want to get rid of it. Now just be careful, this theta plus 10 is in a bracket. And so that entire thing, I am cosing, if that's a word, that entire angle. So I can't get rid of the 10 yet. I first have to get rid of the cos. And how we get rid of the cos is we do shift cos and we put in the ratio. Well, when I did this, when I shift cosed of negative 0,6, I got 126, and I'm just going to keep a couple of decimals, 8698 degrees. Now the question is, who is equal to that? Well, it's not theta, it's this entire angle. So theta plus 10 degrees is equal to this angle. Now I also mustn't forget that I need to write plus k 360 degrees, and k is an element of integers. Now our next step is the fact that every trig equation has 2 solutions in the first 360. So I need 2 solutions. This has only given me 1 solution of 126 degrees. So with cos, how do we find the second solution? And the second solution with cos is you say, right, it's either positive 126 or it's negative 126. And then I've taken care of the fact that there's 2 solutions. My final step now is that I need to isolate theta. So now I know what theta plus 10 is, I need to know what just plain theta is. Now, in one of the previous videos I said with cos, sometimes you actually have to go and split cos up into its 2 separate solutions. Now this is an example where I'm going to have to do that, because I'm going to need to minus 10 degrees on both sides. But if you minus 10 from positive 126, and if you minus 10 from negative 126, you're actually going to get different answers. So I'm going to split this up, and I'm going to say, well, my first solution is when theta plus 10 degrees is equal to a positive 126,8698 degrees plus k 360. Now I've already said that k is an integer, so I don't have to say that again. Or my second solution is when theta plus 10 degrees is going to be equal to negative 126,8698 degrees plus k 360. Now I'm just going to subtract 10 on both sides, and since it's finally my final answer, I can round off to 2 decimal places. So I get 87, and this is still plus k 360. Now just to note here, what's happened is I've minus 10 degrees on that side and I've minus 10 degrees on this side. Now notice my 360 did not change. And it didn't change because when you subtract 10 degrees, you subtract 10 degrees from both sides. You don't subtract 10 degrees from every term. And if you try to subtract 10 degrees from k360, you can't, because it's k360. They aren't like terms. And so the like terms are the 2 angles. So that's why I note the angle changed, but my k360 did not change. Now in the previous video it changed because when you divide by something, you divide everything by that coefficient. And in that case, the k360 changed. Now in my second solution, I'm going to minus 10, and this is when you'll notice why you have different answers. Because when you subtract 10 from a negative, you get a different answer than when you subtract 10 from a positive. Right, and there are my 2 solutions. So we'll summarize our steps after we've done one more example, but basically those were my steps in this particular question. Right, let's try another one. Oh, went past it. Right, there's the second one, which is a sine question. Now, our first step was to isolate our trig ratio. So in this particular question, that was fairly easy because I simply needed to divide by 3. And so I get sine of my whole long angle is 2/3. Now, as I've mentioned before, I cannot get rid of this minus 50, and I cannot get rid of this 2 yet, because it's almost like that everything is inside the sine. So I first have to do shift sine, then the last thing I'm going to do is I'm going to work with getting rid of the minus 50 and the 2. Now when I did shift sine, I get an angle of 41, and I'm going to keep a couple of decimal places, so 8103 degrees. Now the question is, who is equal to that? That entire angle. So 2 theta minus 50 degrees is equal to that. Now I add my plus K360 as per usual. Now that's my first solution. Now I've said this before in a previous video. It's very, very important that you set up your second solution first, and then you go about solving for theta. And I'll explain in a second why. So my next step is going to be set up second solution. So never, ever, ever solve that for theta before setting up the second solution, because it always leads to problems. Now what's my second solution with sine? With sine, my second solution is 2 theta minus 50 degrees would be 180 minus this answer. So I get 138,1897. And I'm just going to write myself a note. Where did I get that from? This was 180 degrees minus this 41.81. Now I don't actually show that in an exam, but I like to just write myself a note so that when I'm studying from this, I know what I've done. And now my final step is to solve for theta. So both of these are very much grade 8 equations now, because they're just linear equations. So my first step is I'm going to add 50 to both sides. So I get 91,8103 degrees. So that's how I gotten rid of the minus 50. I added 50 to both sides. Don't forget your plus K360. Now what I need to do is I need to get rid of the 2. So I divide by 2, but don't forget you divide everything by 2. And since this is now the answer for theta, I can round off. So I get 45,91 degrees, and it's now plus K 180. So notice that was different to when you added 50, you didn't change the 360. But the moment you divide by 2, I must divide everything by 2. So there's one of my answers so far. Okay, now I'm going to repeat the process. First I need to get rid of the 50. So I add 50 to both sides. So I get 188,1897. And don't forget your plus K360. And then when I've divided by 2, I get an answer of 94,09 degrees. And now it's plus K 180. And so there is my second solution for theta. Now the reason why I always say set up both equations first is often what people do is people solve for theta so they get 45.91, and then when they're working out their 180 minus, they minus this 45.91 instead of the original angle. So to avoid that mistake, always just set up both of your first lines first and then go solve your normal linear equations. Great, so let's try one more and then we'll write down a summary of our steps that we've learned. Now this is a tan one. Now tan is wonderful because tan is so much easier than the others, and I'll remind you why in a second. So first of all, isolate your trig ratio, so I get root 3 over 3. Next I would shift tan of root 3 over 3, and that gives me the fact that negative theta plus 30 degrees, and when I shift tan I got 30 degrees. Now my next step is to set up the second solution, and the beauty of setting up the second solution in tan is that I don't actually have to do any hard work. By adding K180 and not K360, by adding K180 and not K360, this automatically generates the second solution. So you don't actually have to worry about doing anything. That's why tan is just probably the nicest of all equations. So that K180 will automatically generate the second solution. And now my last step is just to solve for theta like a normal linear equation. So I'm going to minus 30 on both sides. So I actually get 0, and this is k180. And then if I divide by negative, this is still just 0. And technically this is minus k180 and not plus. But it doesn't actually matter because k is an integer. So it doesn't really matter whether you're minusing or plusing, because basically you can subtract or add 180 degrees. So tan definitely is the nicest. So let's just go over our steps quickly. Our first step, isolate your trig ratio. Second step is to either use shift sine or shift cos or shift tan. So whatever equation you're doing, you need to work backwards from the ratio to the angle. Our third step is to set up the second solution. So I'm just going to say set up both solutions. So don't solve either one of them, set up both first. So just to summarize what the different equations do for us, sine, to set up both solutions, one of them is just the angle, and this other solution, the second solution, is 180 minus that angle. For cos, you just have to do plus or minus the angle, so that's quite a nice easy one. And then for tan, the easiest of them all, basically you just do a shift tan, and then to generate the second solution, you just write plus k180 instead of k360. That automatically generates that second solution. And so my last step is solve for theta. So that's just a normal linear equation. So basically these are the steps of all trig equations that we've learned so far. So these 4 steps will help us in most of the equations we work with. Once we move on to our next level, we'll learn how to adapt this if and when we need. Right, let's try another one. So this one is different because in example number 1, I was always finding the general solutions, whereas in these examples, they've told me that, yes, please find the general solution, and then go and specify exactly which angles lie between negative 360 and 180. So they're giving us a domain. Now, just because they've given us a domain, it doesn't change any of the steps. And we're going to find the general solution, and then we're going to specify. So first step, isolate my trig ratio. That's been done for me. Second step is use shift cos. Now when I shift cos a half, I get 60 degrees. So 3 theta minus 60 could equal 60. So now I've added my plus k360. My next step is make sure that you generate both solutions, so not just one. So normally I'd put a plus minus here because that means that both solutions are accounted for. However, I see that I'm going to have to add 60 to both sides, and adding to a negative number and a positive number aren't the same thing. So in fact, I'm not going to write that, and I'm going to split my solutions into 2 separate ones. So I'm going to call this solution number 1, which means solution number 2 is going to be when 3 theta minus 60 degrees equals negative 60. And I'm only writing them separately so I can go and solve for theta. So now that I've added my k360, I've set up both solutions, and I'm simply going to solve. So I add 60 to both sides, which is 120 degrees, plus my k360. Then I divide by 3 on both sides, except here I need to divide my k360 by 3 as well, so it now becomes k120. And do the same thing below. I'm going to add 60 to both sides, but this time I get 0. So notice I don't get plus or minus 120. You get different answers because of what I said. When you add and subtract numbers to negative or positives, different things happened. So now when I divide by 3, I still get 0, but you divide everything by 3. So this is still k120. Now normally that would be my answer. So either my answer would be 40 plus k120 or 0 plus k120. However, they gave me a specific domain here. So now I need to go to see which of these solutions actually fall in that domain. So what we do is we just start. And we say, right, let's start with 40 degrees. Is that acceptable? Yes, it is, because it's between minus 360 and 180. Now I'm allowed to add, and always check, don't just assume it's 360. I'm allowed to add 120 and subtract 120. So if I add 120, I get 160, and that's acceptable. Now if I add 120 again, I'll definitely be bigger than the 180, so I have to stop. But I could minus 120 from the original 40, and then I get minus 80 degrees. And that's acceptable, and I can keep going. If I minus 120, I get minus 200, and that's acceptable. And if I minus 120 again, I get minus 320, which is acceptable. But now I'd have to stop, because the lowest I'm allowed to go is minus 360. Now I need to check, what about 0? So 0 is acceptable, and I'm allowed to add 120s. So if I add 120, 120 is acceptable, but I'd have to stop there, because if I add 120, I'll be bigger than 180. Now again, I'm allowed to minus 120 degrees, so I get minus 120, and I'm allowed to keep going. So I can minus 120 again, which is negative 240, and then I can minus 120 again, which is negative 360. And so there's actually 5 solutions here which fall in the given domain. Now just to write a note here, the square bracket means up to and including. So you can include this minus 360. This minus 360, which was the last solution, is allowed because a square bracket means up to and including. A round bracket, just out of interest, means up to but not including. Great, so that was a good practice of an equation, and then to specifically take the ones in the given domain. So let's try one more like that. So isolate the trig ratio, done for us. Shift sign, so when you do that, I get that negative theta minus 40 degrees, and shift sign of root 3 over 2 is also 60. Don't forget my plus k360, and I've forgotten out k is an element of integers. Now, my next step is generate your second solution. That's the first solution. Always set up your second solution before you start solving. So negative theta minus 40 degrees. Now for sine, your second solution is 180. So your second solution is 180 minus 60. So that's 120 degrees. So just write yourself a note. That comes from 180 minus 60. And my plus k360. Now I'm just going to solve both of them like a normal linear equation, like I would in algebra. So I add 40 to both sides, and then I'm going to divide by a negative. So I actually get minus 100 degrees, and then technically I get minus k360. And if I do exactly the same below, if I add 40 degrees, I get 160, and then I need to do exactly the same thing of dividing by that negative. So I get minus 160 minus k360 degrees. So technically I have two solutions. It's minus 100 and minus 360. Now that would be the general solution. This specific question asks us to not list the general solution, but those which fall into 0 degrees to 360. So let's have a look. Does minus 100 classify? And the answer is no, because it's less than 0. However, I'm allowed to add 360 and subtract 360 as many times as I want. So if I add 360, I'll get 260 degrees, and that does work. Now you can't add 360 again because, well, you can, but it'll be above 360, and so there's no point. Now I would turn my attention to the minus 160, which also doesn't fit into the right category. But if I add 360, I get to 200 degrees. And again, I can't keep adding because I'll be bigger than 360. So in this case, there were only 2 examples that fit into this specific domain. Right, on to our last question, which is a very, very, very nice question. This would be classified as fairly complex because it draws on a couple of things we've learned. But if we work through it slowly, we'll realize it isn't as bad as we think it is. So we're given that sine of p minus 30 is negative a half. That's our first bit of information. Our second bit of information is that cos of p minus 30 is negative. And finally, we're told that p minus 30 is in the first 360 degrees. So maybe I don't have to worry about k360 because I'm only talking about the first revolution. Now the question says to determine the value of tan p plus 50. Now it doesn't say without a calculator. So I'm assuming I need to solve for p, and then I can use my calculator to work out tan of p plus 50. So why have they given me all this information? Well, because every single trig equation has 2 answers in the first 360. So we can't solve for one value of p, we would get 2 values of p. But this is trying to get us to figure out which one that they're talking about. So let us look at our first bit of information, which is this idea that sine of p is a negative. So if sine of p is negative, don't forget all stations, so both of those are quadrants where sine is positive. So p minus 30 cannot be in quadrants 1 and 2. But our second bit of information tells us that cos of this angle, wherever it is negative, which means I cannot be in quadrant 4 because that's where cos is positive. And because I know my third bit of information, which says it has to be in the first revolution, I know that p minus 30 has to be landing up in quadrant 3. So p minus 30 degrees is in quadrant 3. So when I solve my equation, I need to remember that. Now what equation is there to solve? The equation that I was given is that sine of p minus 30 degrees is equal to negative a half. Now if I do shift sine of negative a half, there's two solutions, don't forget. So p minus 30, if I do shift sine, I get minus 30 degrees. Now technically we should write plus k 360. K is an element of integers. However, we were told that my angle lies within the first 360, so I think this is not going to be necessary. Now where's my second solution? My second solution is that p minus 30 degrees would be equal to 180 minus this minus 30. So that would be 210 degrees. And again, technically, we always write plus k 360. K is an element of integers. However, this, I'm going to put a line through it. I don't need it because of that bit of information. So this is not needed because I was told that my angle was in the first 360. So I can't add 360 and I can't minus 360 because it was in the first revolution. Now we had decided that p minus 30 was in quadrant 3. And so this is not the angle that I'm talking about. Simply because p minus 30 degrees is in quadrant 3. And so that first solution is not the one I want, and number 2 is right. So I can solve for p by adding 30 degrees to both sides. Now let me just take a step back for a second. I just automatically said that minus 30 wasn't right. Why did I say that? I'm sorry, I didn't classify this. I didn't qualify this. Where is negative 30? Negative 30, negative angles mean go clockwise, and negative 30 would be in quadrant 4. So that's where negative 30 degrees would be. Whereas 210 is 180 plus 30. So 210 is in quadrant 3. Sorry, I never actually said that and explained that. So now that I know what p is, I can actually work out what they wanted me to do. They wanted me to work out what is tan of p plus 50 degrees. So let me just write myself a note here. This is p. So p plus 50, and I'm tanning p plus 50. So I'm actually tanning 290 degrees. And they didn't say we weren't allowed a calculator. So I literally just pick up my calculator and write tan 290. And I get negative 2,75. Now you might wonder why it's bigger than 1, because, or smaller than negative 1 in this case, because we've always said that the ratios can't be, but don't forget for sine and cos, they must be between negative 1 and 1, but with tan, they can be anything. So this was a really nice one. Maybe even watch this part of the video again if you're not quite happy with it. This would be classified as a very complex question in an exam because it brings in, your all stations to Cape Town diagram, your trig equations. Very, very nice question. So what did we learn in this video? We learnt about how to isolate an angle if it's got something added to it or subtracted from it. And to be honest, it wasn't very much different to a normal trig equation. All we did was solve the linear part at the end. So just to qualify our steps, isolate your trig ratio, use your shift sine or shift cos or shift tan, set up both solutions, and then solve.